Hello friends, and welcome to your first entirely virtual lab, which I created the week before Thanksgiving for you. I hope you will enjoy getting to watch a lab happen before your eyes and analyze the data. There's not a lot I really need to say about each of these slides, so I'm kind of going to just say very little and let you collect the data. You can trust all the measurements. There's no tricks in here. If you can't read a measurement, zoom in a little bit. This is simply the zeroed balance with the crucible beside it. That's misspelled, and I don't think I can change it because I did this in PowerPoint first. So anyway, forgive my spelling right here. Let's just take that letter out. Ooh, I hate that when I mess up. Anyway, it happens often. All right. Crucible and cover masked. Now you're going to want to be recording data in your notebook, pulling it out of this slideshow and creating a data section for yourself. And you'd like to include both qualitative and quantitative data as much as possible. This is a pretty simple lab in terms of quantitative data and also pretty simple in terms of qualitative. You'll see everything you need to see. So I've taken a strip of magnesium metal and I am polishing it off with a piece of steel wool. Take a look at the appearance of it here in this screen to see what it looked like before the polishing process. Here's what it looks like after the polishing process. The magnesium ribbon is cut into small pieces and placed inside the crucible. There is a black and, orange and almost bluish stain in the bottom of the crucible from a previous reaction that has no impact on this process at all, so you can completely ignore it. This is the mass of the crucible, the lid, and the magnesium. I zoomed in a little too much, so you can't see that the crucible and the lid and magnesium are on the balance, but I needed to do that to get a good picture of the mass. Now the crucible is set on the wire screen on the ring stand and heated strongly with the crucible lid slightly ajar. And there is significance to that crucible lid being ajar, so you'll be asked to think about that at some point in the future. Notice it's heated quite strongly so that the wire screen and the bottom of the crucible both begin to glow a nice orange-red color. This is just a shot of what's happening while it's being heated with the lid removed temporarily, so you can get a sense of what has happened inside the crucible. Now the crucible and the lid and the contents, which have changed since the beginning, are masked again after that first strong, long heating. The crucible is heated again with the lid slightly ajar for another several minutes, and masked again at the end of the second heating. You can see that I have listed, I don't know why they got cut off, the word questions got cut off, but nonetheless, here are a set of 4 questions for you to answer at the end of your analysis, or at any point in the analysis that you would like to take the time to do that. And your lab report is an abbreviated write-up this time, with only the sections that are listed below. There is no separate data analysis. So the title, statement of purpose, materials, and methods, you will need to write a step-by-step procedure, gleaning as much as possible from the photographs that were presented to you. And make sure that you're including a list of all of the equipment that would be needed to perform those steps of your procedure. I think for many of you, I noticed this in your last lab, it might make some sense for you to actually make a separate materials list and then a stepwise set of things that you will do, 1, 2, 3, 4, that sort of thing. In your data analysis, your goal is to calculate the empirical formula of the magnesium oxide that was produced. Okay, that's the compound. And then the last section would be to answer the questions that are shown above. So have fun with that. Let me know at CCL if you have any questions. One last thing, I add a note down here. Since you actually can write the formula for magnesium oxide based on what you know at this point about ion charges and ionic compounds, this gives you a known ratio of Mg to O, to which you can compare your ratio of Mg to O and include a percent error calculation of your ratio to the accepted value of the ratio. So one other thing to add to your data analysis section. Have fun with this, guys.